In Chapter 9, our goal is to learn how to estimate the value of a population parameter using confidence intervals. So, this is going to be our very first step into the world of inferential statistics, where we are learning how to make generalizations from sample data evidence to populations. In other words, in inferential statistics, unlike in descriptive statistics, we're interested in the process of generalizing information that we collect or extract from sample data and see how it applies to the entire population. In particular, in inferential statistics, there are two main areas of interest: estimation and hypothesis testing. For estimation, if we are interested in estimating or finding the value of an unknown parameter or population characteristic, such as the population mean or the population proportion, then we're interested in an estimation process. On the other hand, if anyone makes a claim and we're interested in collecting evidence from sample data to see if that evidence backs that claim or refutes that claim, then we're interested in hypothesis testing. In particular, a hypothesis is simply a claim. For example, if a manufacturer of a new drug claims that this drug can cure a particular disease faster, there might be a need to collect evidence or sample data from persons who participated in some clinical trials just to see if that claim is true. So, in this chapter, in particular, we're going to focus on estimation of an unknown parameter. That will be the first area of inferential statistics. In the next chapter, we're going to focus on hypothesis testing. So for now, as we stated earlier, our focus would be on how to use confidence intervals to estimate the unknown value of a population parameter. But before we get too deep, let's take some preliminary steps by considering how to identify the population parameter of interest in any given scenario. So we begin. If we take this example, in this example, suppose we want to estimate the proportion of adult Americans who believe that the amount they pay in federal income taxes is too high. Now, it is unreasonable to expect that we could survey every adult American. Instead, we use a sample of other adult Americans to arrive at an estimate of the proportion. So, that brings us to the question: what characteristic of this population of adult Americans are we interested in estimating here? From what you have learned so far in this class, how would you represent that parameter or that population characteristic symbolically? Here is a quick pointer for us. We are interested earlier, as we said, in estimating the proportion of adult Americans who believe that the amount they pay in federal income taxes is too high. That is the population parameter we want to estimate. So, to begin with, let's write out the population parameter and let's give it a symbolic representation. So, as expressed earlier, the population characteristic or parameter would be this proportion of adult Americans who believe that the amount they pay in federal income taxes is too high. That is what we have written down. Since we are talking in particular about proportion in the entire population of adult Americans, we represent that by capital P or uppercase P. Then we proceed to the next example. A researcher wanted to determine the mean number of hours per week, Sunday through Saturday, that the typical person watches television. Results from the Sullivan Statistics Survey 1 indicate that the sample standard deviation is 7.5 hours. What is the population parameter we want to estimate here? How would you represent it symbolically? Well, it goes without saying that this researcher wants to estimate or determine the mean number of hours per week the typical person spends watching television. That would be the population parameter we want to estimate. And symbolically, you might recall we use mu. Let's write that down too. So, as said earlier, the population parameter or characteristic would be the mean number of hours per week that the typical person watches what television. And this would be represented symbolically as, since it is mean, we represent it as mu. For this chapter, these are the two types of population parameters that we are going to learn about. There are other parameters of a population that we can define, but at this level, we limit it to population proportion and the population mean. Note that in general, these two are usually unknown, and our goal is to use sample data evidence to find a best educated guess for these unknown parameters. So, having defined the two types of population parameters we're going to be talking about in this chapter, we proceed to look back at the distinction or difference between the two types of inferential analysis that we can conduct at this level of statistics. There are two: confidence interval estimation and hypothesis testing. Having identified the two types of inferential analysis that we can conduct, statistically speaking, we might ask the almighty question here. Of these two types of inferential statistics, how do I know which one to use and when? To answer this question, you need to ask if you want to find a possible educated guesstimate of the unknown population parameter. So if it's all about just finding an educated guess or estimate of an unknown population parameter, your go-to is confidence interval estimation. However, on the other hand, if you already have a number in mind, take for instance, Michelin tire says this set of tires will last 60,000 miles on average. That is a claim. So this manufacturer already gave us a guesstimate. So we have a guesstimate in mind already. And if you want to test if claims made about that guesstimate is true based on available sample data evidence, then your go-to in that case would be hypothesis testing. So to test what we have just discussed, let's consider the following examples. In each of the examples below, which type of inferential statistical analysis will you conduct? For example, if the question said, what is the average amount in dollars spent on meals by students at some college called Kirtland Community College each week? In this case, we're trying to find an estimate, an educated estimate at that, of the average amount in dollars spent by students at this college. So in this case, that would be trying to find a possible educated guesstimate of an unknown mean. That takes us to using confidence interval estimation. So that would be the appropriate kind of inferential statistics to perform to answer this question. Then, for the next example, we're told that the trade magazine QSR routinely examines fast food drive-through service times. Their recent research indicates that the mean time a car spends in a McDonald's drive-through is 167.1 seconds. So there's a claim there. Take note of that. A McDonald's manager in Salt Lake City feels that she has instituted a drive-through policy that results in a lower drive-through service time. A random sample of 70 cars results in a mean service time of 163.9 seconds. with a standard deviation of 15.3 seconds. So, if we are to determine whether the policy is effective in reducing drive-through service times, which type of inferential statistics will you conduct in this scenario? Here is the tip for you. Well, there is already a recent research that claims that the mean time that a car spends in a McDonald's drive-thru is this value. So there is a claim already. Our goal is, based on available sample data that you're collecting from the 70 cars, will you have enough evidence to test this claim to see whether it is true or false, or whether there is a significant difference in the results you are getting from what has been established, or what the evidence you have only backs up that initial claim? In this case, that would be going back to hypothesis testing. We need to test a claim that has been made. So in this case, you have hypothesis tested. So with that said, whenever we want to estimate an unknown, we use confidence interval estimation. If we want to test a claim, we use hypothesis testing. This is the official conclusion of the introduction to inferential statistics, and we're going to narrow down to confidence interval estimation in the succeeding video.